Perfect. Do we write down this one yesterday? This is where we stopped yesterday?
Yeah.
Okay. So it contains, for the skeleton, you have not just bones, but ligaments, which connect bone to bone, cartilage, which is between the bones in your joints. The main purpose of the skeletal system is to have a framework that protects your organs. You know, think about where your bones are located. Think about the ones that protect. They're around your most vulnerable organs, around your heart, around your lungs, around your liver. So your rib cage protects those organs that would be damaged without them there. Then you also have your spine. What is inside your spine?
Your nerves.
Yeah, your nerves. And so if those are damaged, what happens? You could be paralyzed, you could die. They're incredibly important. And so your spinal cord, which is your nerves, are encased in bone, along with your brain. Your brain's also encased in bone because those are very important organs, which if those are damaged, it leads to all kinds of problems or very serious conditions or even death. A concussion, all that is your brain hitting your skull. So in a concussion, you know, your brain is swimming in this fluid, it's floating. And when you bump your head really hard, your brain hits your skull. It's not even damaged. It's not even, you don't even see bleeding. You don't see cells that have died. It's just your brain hitting your skull that caused a concussion. And because your brain hits an area of the body, it changes how it works. And concussion can be very serious. It can be lifelong effects because your brain doesn't work the same way after it's been hit. So it can change the way it works chemically, electrically, which can lead to all kinds of different problems. So concussions can lead to things like depression. It can lead to loss of focus, inability to learn. It can lead to blurry vision, migraine. It can be very serious and very debilitating. And so those organs need to be protected. And so bone does that. So ligaments, I mentioned this the other day, they connect bone to bone. And so one example of that would be your ACL, which you can see right here. Your ACL is a ligament that connects your femur, your thigh bone, to your tibia, your shin bone. So ACL stands for anterior cruciate ligament. And so the L at the end stands for ligament. So within your knee, you have ACL, MCL, PCL, MCL, those are all LCL. Those are all different ligaments within your knee. They're in different locations. So if you twist your knee and hear a popping sound, probably what's happened is a ligament has torn. And so it's a very common knee injury to tear your ACL or MCL, PCL, LCL, any of those ligaments in your knee. Yeah.
So if you break a bone in your knee, are you ripping ligaments as well?
It depends on where you broke it. Generally, if it's just one fracture, no, it's generally just the bone that's broken, but you certainly can have both. That can certainly happen. There's one condition where it's called Osgood-Schlatter, where this right here, the ligament right here breaks the bone off the knee. And so this pulls the tibial bone away and a chunk of bone leaves. It happened to me when I was a teenager. It was really painful. It's common when you're growing and you're really active and you play sports, but this right here can pull off bone. So you can have ligaments pull bone off. That can happen. And certainly sometimes with injuries, you can certainly tear your ligaments and break your bone, but it's usually one or the other. It's usually not both, but it can be both.
If you don't break your patella, what would it?
Yeah, I mean, generally it would just be the bone that's broken, but you certainly could also break ligaments as well. That definitely is a possibility.
Okay.
And then tendons connect muscle to bone. So you have a tendon up here. So the bottom part right here, this is a ligament, patellar ligament, which connects your kneecap, your bone, to your shin. But you also have up here a tendon that connects bone to muscle. It connects your quadriceps, your thigh muscle, to your knee. Tendons are also found in your fingers. So the part you see right here, you know, these string-like things that come out, those are tendons. They connect muscles to bone. You have a muscle in your arm that connects to your fingers and makes them extend. And that's what you can see right here in this picture. So you can see, and these, you also have ligaments in your wrists that connect the bones together. You have 8 wrist bones that connect. But you also have muscles in your arm that connect to your fingers to make them extend and flex. And it shows in this picture your MCL, LCL, ACL, and then PCL. They'd be back here. Okay, the next system, muscular system. So we talked about the skeletal system, but now we're going on to muscles. So one purpose is to move body parts. That's the main purpose of muscles, but they have other jobs too. Maintain posture is important. They provide a source of heat. Muscles have a lot of heat stored up because they carry a lot of blood, and blood is the main source of heat. And the more muscles you have, the more hot blood you're going to be. So you're not going to get cold as easily if you have more muscles. Muscles carry a lot of heat. They burn lots of calories too. Let me go see what those guys do. I'll be right back. So make sure the teacher was in the room, but they're fine. Okay, let's go back to this. Sorry about that. So we have different kinds of muscles. Some move voluntarily, which means you can choose to move them. And those of you are skeletal muscles. And that's what we think of as muscles. Think about, our biceps and our arm that makes our arm flex. We think about quadriceps in your thigh, calf muscles. Those are all muscles that you use to move. But you also have other muscles that move on their own, that move without you thinking about them. And so those are in your organs. You have muscles in your blood vessels that pump blood through your body. You have muscles in your heart. You have muscles in your diaphragm, which makes you breathe. Think about that. You have muscles in your intestine that move food through, and your esophagus. So you have muscles all over that are called smooth muscles that are involuntary. You don't choose to make them move. They do it on their own. Now you can override certain muscles, like your diaphragm, for example, and you can decide to control your breathing. But for the most part, breathing is not voluntary. For the most part, you don't think about it. You breathe without consciously choosing to breathe. Heart, some people have been said to control their heart and make it stop and make it beat at will. So very rare, but there are certain people who have claimed to do it to control the heart. But for the most part, the heart is totally involuntarily, and we don't really, most people can't control that. It works on its own. Going on to the next system, nervous system. And so all of the green is your nerves coming out of your spinal cord. And you have some nerves come out of your brain. And so you have spinal nerves that branch out from your spine. And then there's some cranial nerves which come out from your head, from your brain. They go along your face, along your neck, and your eyes, your ears. So the nervous system contains your brain, your spinal cord, the nerves that come out, all the green you're seeing on there, sensory receptors that would be found in places like your eyes that detect light. So in your eyes, you have cone cells which detect different colors. So one cone cell detects only green light. Another cone cell detects only red light. Another one only detects blue light. And those are the 3 colors they detect. Now, based on that, though, you can get a wide range of colors that you actually see. But those are the receptors in your eye. Then in your mouth, you have taste buds. You have taste receptors, different nerves that are fired based on the chemicals that are in your food. And you get different tastes based on that. In your nose, you have other receptors that give you a sense of smell. And so there are chemicals in the air that will hit your nose and make you have certain smells. And so when you smell something in the air, it's the chemicals that have gone from the air into your nose that make you smell that. And so taste and smell are both chemical based. You have certain chemicals that you either had on your tongue or in your nose that then make you have a change, which is then what you detect as a taste or as a smell. So those are receptors that tell you what's happening around you or in your body. So they detect changes inside and outside the body. That could be changes like a new smell, or it could be something like a temperature change. So nerves receive information and they respond to the information. Now they can over time though wear down and just stop working. For example, a smell. You have like a piece of pizza, like a whole pizza in the room, and the pizza smells really good and it's really a strong smell. But you stay in the room for like 30 minutes, you won't smell anymore. And somebody new comes into the room and they smell it right away. The pizza to them is overwhelming, but to you don't smell anymore. Your body will stop sending signals to the brain if it's repetitive. And so if you stay in the room with a really strong smell for a while, you won't smell anymore because the brain recognizes it as a repeating sensory impulse, which you can ignore. And so that would be true, especially for smell. You get used to certain smells. And like that's why in your house, you might not know that there's a certain smell in your house. And you have visitors come over and they say, your house smells like this. And you don't realize that because you're used to it and your body just doesn't recognize it anymore.
So like if you, like during a world war, like say you were in a Nazi prison camp and it really stunk there, would you eventually just get used to it?
It depends. Now, there are some really pungent smells that are, really unpleasant smells that you don't get used to very easily. But for the most part, yes, most smells, even really bad ones, you eventually can get used to lots of different smells if you're exposed to it all the time. Now, if it comes and goes, no. But if it's a constant smell, then many smells you can get used to, but not every. There are certain ones you can never get used to. It just depends. There are some just really horrible smells that your body would just recognize as a really bad smell, which it would constantly tell you it's dangerous, get out of the situation. Like basically that's what it is. Like a really bad smell is usually something that's not good for you. And your body's telling you it's not good for you, get away from the smell. That's usually why your body's telling you that. And so if it was in like decaying bodies, for example, if they're smelling dead bodies, that's really dangerous. That would cause disease. And so the body would not get used to that smell because it's telling you to get away from that source of infection. So that might be, and I've heard stories of that where they never get used to the smell of people who are being burned or people who are dying. Like there's certain smells they never really get used to. And those would be smells that they really never were able to get over. So it just depends. But like sewage, probably get used to the sewage smell, like things like that. But yeah, like really, really bad smells, probably not. Yeah.
For something like that's good for you, so like apple cider vinegar,
Mhm.
like it smells really bad,
feel like it's good for you. So like,
Well, I mean, in a large amount, it's not good for you. It's an acid. And so if vinegar is very acidic and on its own is not that great for you. I mean, you usually do want to take it with other things. And so it is a very strong acid and your body reacts to that. So it's good when you mix it with other things, but on its own, it's not the best thing to have on its own. It can really hurt your teeth. It can hurt your stomach because it's a very strong acid. But yeah, I mean, there are certain things like, like broccoli, for example, Brussels sprouts that are really bitter, but they're good for you. It depends on the person. Some people have very strong bitter tastes and they don't like bitter things like coffee, broccoli. And that's just how the body has been developed. But other people like those things. It just depends on how your genes are arranged. Based on your genes, you might like or dislike certain things that are good for you. And that would be an example of that. So like cilantro, some people love cilantro, others hate cilantro. That's all due to your genes.
well, can like you see some things as really bitter and some things as not? It's like coffee, unless with creamer in it, seems really bitter to me. But like I love Brussels sprouts.
Yeah, so that's a little bit unusual. It definitely happens, but that's more than usually if somebody likes one bitter thing, they like other bitter things, but it happens. It's just not as common.
I like coffee, but I don't like broccoli.
Yeah. And lots of times you kind of, when you're younger, you don't like really bitter things, but as you get older, you tend to like them better. And that's to do with your taste buds. When you're younger, you have a lot of taste buds. And so you prefer sweet things when you're younger because of that. And as you get older, your taste buds wear out. And so people who are older like really salty things. They put salt in everything because they can't really taste much. And they like really bitter coffee because their taste buds are not very strong anymore. But when you're young, when you taste things really well, you prefer things that are sweet. And so I think it's just common for somebody who's younger to not like things like broccoli and Brussels sprouts. It's unusual to like those things when you're really young.
Is that why most older people like drink black coffee?
Right, because their taste buds have worn away. And so they like bitter things. So to them it doesn't taste bitter. So then they don't taste the full bitterness that people who are younger would taste. Back really fast, we go through all these ones. So it carries impulses from the brain to the spinal cord to the muscles and glands. And so this controls movement and it controls how the glands work. Endocrine systems, this would be all the hormones in the body. So this would be found all over. There are multiple glands that secrete different hormones and they are chemical messengers. Hormones are chemical messengers in the blood that tell the body to do certain things. Like in your brain, for example, you have the pineal gland. Do you know what that does? Have you heard about that one before? Pineal gland? Melatonin? It makes melatonin. Yeah. So melatonin is a hormone that tells you it's time for bed. And you begin the process of going to sleep. When you are younger, your sleep cycle gets flipped around. When you get to be, teens, you start to go to bed later and later. It's because of the melatonin is secreted later on in night. So when you're younger, it might be 8, 9 p.m. when melatonin is secreted, and that's your bedtime. But when you get to be high school age and older, it might be 11 p.m. or midnight before you have melatonin secreted. And so teens go to bed later, not just because they're choosing to be rebellious, but because their body actually is wired that way to go to sleep later. Now, you all heard about blue light. I'm sure how there's blue light filters because blue light is a signal to your brain that it's daylight and to be awake. And so if you're looking at your screen with blue light for bed, your brain thinks it's daylight and it gets confused. And so it can really disrupt your sleep because your body will stop secreting melatonin and you don't have restful sleep.
Wait, so why do like adults go to bed really early?
Because it changes when they're older. And so in your teens, like about 18, 19 is when it gets the latest. That's maybe 1 a.m. when you have bedtime. But then after that, it goes the other way. And it slowly goes back earlier until when you're really old, it's maybe 8 p.m. again. I mean, so it just goes in a cycle. from when you're young, it goes later and later until about 18, 19 years old, and then it goes earlier again.
So I heard that if you like the medicine you take to go to sleep, melatonin,
Mm.
is like just tricking your brain. Is that true?
Well, I mean, not about tricking your brain. I mean, it's telling your brain to do something, right? I mean, it tells your brain to go to sleep. So, I mean, it can definitely help. I mean, melatonin doesn't help everybody, but it can certainly be helpful to some people who cannot sleep. So it's worth a try. And also blue light would be also avoiding screens is also very important.
So like sometimes I take melatonin and it doesn't really work. Is that just psychological?
It might be. Yeah, I mean, for different reasons. I mean, your body will break it down. You won't have a whole lot of melatonin get to your brain. And so it just might be the amount getting to your brain is not enough to make a change. And so you might try different product, like different brands of melatonin and see if that makes a difference. But it doesn't work for everybody. It's not like a sedating effect. You're not going to feel sleepy with melatonin. Like it's not going to be like a sleeping pill, or like Benadryl, where you feel drowsy. It's not going to be like that. It's not that pronounced of an effect, but it can help you have restful sleep. But it's not going to put you to sleep, if that makes sense.
I take melatonin before like trips and things because I got fall asleep beforehand, and it works on me before I'm mom. Like it makes her feel really like weird. Like she doesn't really makes her feel like.
Mm-hmm.
Why is that? Is this something that's something?
Yeah, I'm not sure. I mean, that's just how your brain or your body breaks it down. And, because it's breaking down the drug in your body, right? And so for her, it might not break it down to be helpful to her. It might be breaking it down to the point where the chemicals interfere with sleep, not helping. And so I'm not sure in her case, but everybody's body is different based on their genes. And you break down medicine in different ways. And it doesn't work the same way. So Benadryl can make people actually really hyper in certain situations. Based on how their body breaks it down, they might actually not feel sleepy with Benadryl. Others get very sleepy with Benadryl. And that's to do with your genes and how your body metabolizes that drug. Other ones on here, you got the pituitary gland, that's growth hormone secretion. And so if you have a large pituitary gland, you're going to get very tall. Growth hormone secreted more for people who are tall, people who are short.
Are there genes for like determining how much you like a sweet thing?
Yes. Yeah, there's certain genes that tell you if you prefer sweet things versus salty things. Yes. So there are certain genes you can look at to know if you would like things like chocolate, for example, if you prefer dark chocolate or milk chocolate, if you prefer sweet things or salty things. Yeah, there are certain genes that would make you prefer certain tastes over others. And the hypothalamus controls a lot of different glands. And so that's the master gland that controls all your other glands in your body. Thyroid glands, that controls your metabolism. So if you have low thyroid levels, you're going to feel very tired and sluggish. You might gain weight because your body's not working correctly. It's low metabolism. Or if you have too much thyroid, you might feel really sweaty and you might not be able to be anxious. You might not be able to sleep and calm down. So your thyroid controls metabolism. It's very important for that. Thymus gland, that's mostly when you're really young. About age 12 is when it stops working. It turns into fat as you get older. But it's basically as a school for white blood cells to learn how to fight infection. And so white blood cells, when they're immature, they go to the thymus gland to learn how to fight viruses and bacteria. But after you get older, you don't need it anymore, and it just goes away. Yeah.
How do they learn how to do that?
So the body trains the cells to understand what is the body and what's not the body. And so the white blood cells are looking for proteins that are foreign. And to do that, it needs to know what the body actually looks like. And so it's learning the cells and the protein structure of the body cells to know what's not part of the body. And then after that goes off to fight viruses and bacteria. You have the liver, and then you have adrenal glands right here above your kidneys. So adrenal glands secrete adrenaline. That's one of the things that they secrete. So adrenaline would be important for fighting off. If you feel like you're in danger, it's called fight or flight, where you either fight the danger or you run away from the danger. So adrenaline starts to make your heart races, you breathe faster, you might sweat, your eyes might dilate, they get bigger. Time slows down. You're taking more information per second. And so you're able to respond to whatever's around you. That could be for, again, if you feel like you're in danger, or it could be like in a sports game when you know this is really important and you need to really focus on winning the game. Or it could be if you're just excited, or if you're really happy, or like go to Six Flags and a roller coaster. Those would be times when you would have adrenaline secreted in the body.
Is that why you feel butterflies in your stomach? It's like right in the area.
Exactly.
It's not actually from your stomach, it's not from there.
Well, no, actually, it is the stomach too. So adrenaline will also affect your intestinal area as well, and so it's going to. You might throw up. It might make you nauseous, and so why does it do that? Well, digestion takes a lot of energy, and so if you are in a high stress situation, if you have to perform, if you have to like run a race, if you have to speak in front of people, your body needs to devote all its energy to doing that thing, whether it's speaking in front of everybody or it's running a marathon. Your body is in high stress situation. Digestion takes a lot of energy. So the body might reject food because it doesn't want to spend energy to do that. And so adrenaline would have that byproduct. And so people might not feel hungry before a race or before, before speaking for the class because of that. Pancreas secretes insulin and glucagon. So those are two things that would be for blood sugar levels. So insulin removes blood sugar from the body. So if you have too high blood sugar, then you have, it's called diabetes, and the insulin's not secreted properly. So you need to take insulin to get your blood sugar levels back down. That's for digestion and for metabolism. And then the last ones we'll talk about when we get to the reproductive system. But those are the ones that for the endocrine systems, all the hormones, these are just different chemicals that the body secretes. And these are just some of them. And we don't have to write these down, but that's just a listing of the ones that we talked about. Cardiovascular system. So this is your blood system. This contains your heart, your arteries, your veins, capillaries, and blood. So the heart pumps blood through the body. That's its job. Blood transports gases, nutrients, hormones, and waste products. So blood's purpose is to transport oxygen to the cells. And oxygen is how the cells get energy. It needs it to burn sugar. So oxygen is required to burn sugar. And so the cells take in oxygen to burn sugar and they get energy that way. That's why you breathe, is just to get oxygen so you can burn sugar. And then you expel carbon dioxide. So after the cells burn sugar, they give off carbon dioxide. And the blood takes that up and expels it into your lungs. Blood carries hormones, nutrients, water, proteins, and waste products. The kidneys, you can see them right here, will filter out water and liquid waste. They go into the bladder to filter that out. The liver will filter out toxins from the bloodstream, along with the spleen. And so there's several organs that clean the blood and remove things that are harmful, like pathogens, like bacteria and viruses, or remove things like that are toxins or waste products in the body.
Is that what supposed to go to like a dialysis company? Or like...
Yeah, that'd be for your kidneys. Yeah. So dialysis would be if your kidneys aren't working properly. Yeah. And so dialysis would be cleaning your blood for you. And so the kidneys normally clean your blood, but if they're not working, then dialysis would be the one that actually cleans the blood. You have to go about every, 2 or 3 times a week for a few hours to get your blood cleaned if your kidneys aren't working properly. And then the intestinal area down here. So blood takes up nutrients from the intestine. And that's how you get nutrients from your stomach into your blood. The intestinal area is where digestion actually happens. And the blood pulls up water and nutrients into the body.
I thought that it only like gets nutrients from the Or does it
Yes, the small intestine would be the majority of nutrients. That's correct. Yeah. Large intestine would be more of just pulling out water.
would
And
water still go in the bloodstream?
yeah, some water would be pulled out in the but you're correct. And that's what it's showing us large intestine right here. But yeah, small intestine, which is not really showing this picture, would be right here. And that's where the majority of digestion takes place. That's correct. Yeah. And then lungs up here, that's where oxygen takes gas exchange takes place. Oxygen comes into the blood, carbon dioxide goes out. So the ones that are in blue versus red, the blood's not actually blue. They're showing it this way, but it's not actually blue in your body. It's never going to change from red to blue. But bright red blood is full of oxygen. And then blood that's not is usually a dark color. Usually it's dark red, maybe looks like a purple, even like maybe a black color in certain situations. But they just call it dark red. They don't really call it blue. But so what they're showing here on blue is just deoxygenated blood. It's blood that has lost oxygen, and it's gone from bright red to dark. And so you have arteries, which carry oxygenated blood from the heart to the organs. And then you have veins, which are in blue on here, which carry blood that has no oxygen back to the lungs. And that expels carbon dioxide. And so the veins carry carbon dioxide back up to the lungs. Arteries in red carry oxygen to the cells. And so it's a lot worse to have an artery cut in your body than a vein, because an artery is coming from your heart outward. And so signs of having an artery cut would be bright red blood coming out, and you'd see it gushing out in spurts because your heart's pumping, right? So every time your heart pumps, it would gush out blood. So then you'd see it spurting out, like it'd stop and spurt again. And so if you have like an artery, like your carotid artery right here, if that's cut, that's fatal in a few minutes, even maybe in a few seconds, depends on how bad it's cut, because your heart is pumping out bright red blood. And it's this right here. It's this red one right here. So instinctively, you're going to want to close that. You're going to feel that. If you have one cut, if you have an artery cut, you're going to want to apply a lot of pressure right away. Because if you don't, you're going to lose blood. In a few seconds, you're going to pass out from the blood loss. But if you have a vein cut, you're going to lose blood, but it's not going to be nearly as much blood. Because it's low blood pressure, it's going the other way.
Are veins more close to the surface and the arteries?
Not necessarily. Like the artery right here, you can feel it's like right next to your skin. So some of them are, but not all of them are. Like in your arm, you can see like all the veins are right here, arteries in the middle. So sometimes they are, but not always. It just depends on the body. If you get blood donations, or if they give an IV, they always choose veins and not arteries. And so these right here are veins they choose, brachial vein. And that would allow you to have a gentle movement of, if you're having an IV, for example, to have a gentle release of certain medication into your body. It's able to move throughout your entire body. So the vein would carry it to your heart, which would pump it out through your whole body. And so that would allow for medication to go throughout the whole body. And you wouldn't have a lot of bleeding either. And so by having a vein chosen, blood will not spurt out. And you won't have a lot of blood loss with an IV or blood donation.
So have they ever done it with an artery?
They can. It's just you have to be more careful about that. So it definitely is possible to use an artery. It's just not as commonly used for a few reasons. And so almost always they're going to choose a vein, because by choosing a vein, you're going to have less blood loss. You're also going to allow it to go to your heart, which will then go to your whole body. If you choose an artery, it's going to be more localized. It just stay in your arm, for example. But if you choose a vein, that vein goes back up to your heart, which pumps it down through your entire body. And so that allows you to have medicine go to your whole body. And so arteries would not be chosen generally, unless there's a certain purpose behind it. But almost always will be a vein that's chosen. They might have, if they want to move it to your heart, like a PICC line, they could use your femoral artery to go up. So they might insert a needle from your femoral artery in your thigh up to your heart. If they want to have something inserted into your heart, they might use an artery to do that. But it's always going back to the heart. That's the main purpose of having medication and IVs, is to go to your heart to then be pumped throughout your entire body. Lymphatic system.
So do arteries have like a protective thing to prevent them from being cut if it's too much stuff?
Yeah, they're very thick. Yeah, they have a very thick muscular wall. And so it's not easy to cut an artery because they do have they have fat around them, usually muscles. So yeah, it's you have to have a really deep injury, really major cut for you to have an artery severed. Yeah, it's not easy to do.
So when you get bruises or whenever you get like scrapes or cuts, is that almost always a vein?
Or it could be a very small artery. But yeah, I mean, generally it's not going to be a major vein or major artery. If you get a small cut, it's going to be small blood vessels, which would not be called arteries or veins. They'd be very small. They'd be all arterioles, which are small arteries, or venules, which are small veins. And so, yeah, if it's not a deep cut, it's not going to be a whole lot of blood loss. It's also more dangerous to have a cut lengthwise, like because you have these arteries and veins going this way. So if you were to have a lengthwise cut along a vein or an artery, you're gonna have a lot of blood loss. If you have a cut this way, not nearly as much blood loss. And so a cut this way can be fatal. If you have a cut through a vein this way, you can lose enough blood that you would die from that. But a cut this way, usually not fatal because the blood loss you have is a lot smaller that way.
It feels like
So-
small, it still wouldn't matter.
Oh, yeah, but small wouldn't matter. Yeah. But if you have a cut through the vein you're seeing along here, or through the artery you're seeing along here, that'd be a different thing. So lymphatic system, so that's all in green on here. And so those are lymph vessels. So they're like blood vessels, but they don't carry blood. They carry fluid. It's blood plasma. They carry this water, protein, and salt mixture throughout your body. That's what lymph fluid is. So it comes from your blood system, but it's not your blood system. It's just water with white blood cells, protein, and salt.
What, I'm saying, is it still your heart?
Yeah, it's still your heart. I mean, it's a blood pressure from your heart that makes it move, along with some muscles that can also allow it to move.
So if a surgeon's like doing an operation, how do they avoid bleeding to death?
Oh, yeah, that's good. So there's a few things they can do. And they know where to cut. They make very small cuts, first of all. And they would know to avoid certain arteries and veins. So they would, if they're cutting along here, they would know to avoid your carotid arteries. They wouldn't cut that artery. They would be cutting smaller blood vessels, which would have less blood loss. They also use sponges. And so they would put sponges inside wherever you're cut so that will help prevent blood loss. And they might even use clamps if they need to. So they might, if they do need to cut an artery or a vein, they can clamp it shut. Like if they're doing heart surgery, they're going to clamp those arteries and veins shut around the heart. And so that's a few things. Clamps or sponges would be the two things that they would do, along with just having small cuts and knowing to avoid certain arteries and veins. But there always is some blood loss, but they try to limit how much blood loss you have.
I see.
Okay. Yeah.
If it's a small cut, how do they like reach their hand in?
They can't. So they can use robots in certain situations. What they also do is they have a camera they insert into the hole where they cut. And the camera then lets them see inside, and they can then use another hole to move the equipment into it. So they might use, so it just depends on the surgery that they have, but they might be able to fit small scissors into the hole to just cut whatever they need to cut, for example, or stitch it up. So it just depends on the nature of the surgery, but they can insert a camera into one side so they can see if they're actually cutting open that area. And even robots can be used in certain situations. They can put them inside the body to do certain operations as well. But that's more rare. But for the most part, using the camera lets them really limit how much cuts they have to make.
What about like C-sections? Because
Mhm.
my mom had a bunch of C-sections and the camera was kind of really big.
Yeah, yeah, that's unavoidable. You know, with the baby, you have to make a cut for the baby to come out, and so that is going to be very big.
Like, how do you not bleed to death? Because like, you can,
hmm Well, because what they cut is not major arteries for one thing. I mean, so the stomach area, where they cut, does not contain major arteries. They also have a lot of sponges that they're able to insert into that area, which keeps the blood from flowing out. And so the combination of cutting where there's not major arteries and using sponges would let them, and if they have to, they'll use clamps and clamp arteries. But so those would be what they have available to them, which keeps you from bleeding to death. But it's not like cutting, you know, say your arm or your neck where you have major arteries and you don't have them in your stomach area. So it transports some plasma back to the blood system. And so it's moves in between the blood system into the lymph system. Lymph fluid helps clean the body. It helps prevent infection. It carries white blood cells through the body. It also carries fat from the intestinal area, you know, from what you eat. It carries fat to the blood system. And it transports white blood cells through the body. That's just the main purpose, is to carry white blood cells through the body. And so this system is used really to fight infection. Its main purpose is to make white blood cells and to fight off infection. If you were to cut these veins, you would just see clear fluid come out. And it's just basically what it is. It's blood plasma. You have a lot of them up here in your neck area. So if you're sick, your doctor is going to check under your chin right here. He's going to feel along here. He's feeling for your lymph nodes. And so if those are swollen, you have an infection. And so what he's doing is like he's feeling to see if these are swollen. If they are, it's white blood cells are piled up in that area, and that's a sign of infection. So a common area for you have swelling would be your neck area. Another place we have a lot of them is your armpit. And so those would be two places you might have an infection where you have a swelling up of a lymph node based from the infection.
Is it bad if you like get a cut?
For the most part, I mean, you're gonna have some fluid come out, you're gonna have some fluid loss, but it's usually not that serious. It'd be a lot more serious to have your blood cut, so your blood veins cut or your blood arteries cut than your lymph vessels cut.
Like an infection.
Yeah, that could be serious. That could be very serious in certain situations. But your body can fight off most infections, but yeah, certain times you do have it where it just you can't fight it off. That'd be a real problem. Okay, there's no homework today. We didn't finish up the section yet, so don't worry about homework. We'll finish up 28.1 tomorrow. Have a good day.
So like, as long as it is a